Hi friends, I'm Mrs. Gradney, and today we'll be finding a times 10 pattern in the place value chart. Grab your Lesson 2 template and make sure it's in a personal whiteboard, and then pause the video and label the ones, tens, hundreds, and thousands like you can see here. Now pause the video and write a 10 times multiplication sentence to show the relationship between 100 and 1,000. Here are two different multiplication sentences that you may have written. Both of them correctly show the relationship between 100 and 1,000. Let's read them both aloud. 10 times 100 equals 10 hundreds equals 1,000. 10 times 100 equals 1,000. In the first multiplication equation, we showed how we regrouped 10 hundreds to make 1,000. In the second multiplication equation, we left out the 10 hundreds because we did that part in our heads. Let's try another one. Pause the video and draw place value discs. Just use dots for the place value discs to find the value of 10 times 1,000. Did you draw 10 discs in the thousands column like this? What multiplication sentence does this represent? It represents 10 times 1,000 equals 10 thousands. How else could these 10 thousands be represented? Well, we know we have 10 units of 1,000, and we know that whenever we have 10 of any place value unit, we can bundle or compose them to make one of the next larger unit in the column to the left. What do you think this next larger place value unit after thousands might be called? Make a prediction. If you said 10 thousands, way to go. Label your 10 thousands on the place value chart now. And now we can continue our equation and rename 10 thousands as one unit of 10,000. Let's read this whole equation. 10 times 1,000 equals 10 thousands equals 1 10,000. Let's move another place value unit to the left. Pause the video and draw place value discs to show 10 times 1 10,000 and write a multiplication sentence to match. Did you draw 10 place value discs in the 10 thousands column and write an equation like this? 10 times 1 10,000 equals 10 10,000s. But what do we know we can do when we get 10 of any place value unit? We can compose them to make one of the next larger unit. But what do you think this next larger unit might be called? If you said 100 thousands, you'd be correct. Label the 100 thousands on your place value chart now. And now we can continue our equation and rename 10 10,000s as 100,000. Let's read this whole equation. 10 times 1 10,000 equals 10 10,000s equals 100,000. Let's move another column to the left on our place value chart now. Pause the video to solve for 10 times 100,000 by drawing discs and writing a multiplication sentence. Hopefully you drew 10 place value discs in the 100,000s column and wrote your multiplication sentence like this. 10 times 100,000 equals 10 100,000s. Now we know when we have 10 of any place value unit, we can bundle them to make one of the next larger place value unit. So we can bundle these 10 hundred thousands to make one of the next larger unit. And the next larger unit after hundred thousands is called millions. Everyone say millions. Label millions on your place value chart now. And now we can continue our multiplication sentence by renaming 10 hundred thousands as 1 million. Let's read this whole equation. 10 times 100,000 equals 10 hundred thousands equals 1 million. Let's quickly review the pattern we just modeled on our place value chart as we move from right to left. Say the multiplication sentences with me as we move from right to left. 10 times 2 ones equals 2 tens. 10 times 2 tens equals 2 hundreds. 10 times 2 hundreds equals 2 thousands. 10 times 2 thousands equals 2 ten thousands. 10 times 2 ten thousands equals 200 thousands. 10 times 200 thousands equals 2 millions. Now we can also talk about the relationship of the place value units as we move from left to right. As we move from right to left, we multiply by 10. But what's the opposite of multiplication? We know division is the opposite of multiplication, so as we move from left to right on the place value chart, we can divide by 10. Read the division sentences with me as we move from left to right on the place value chart. 2 millions divided by 10 equals 200 thousands. 200 thousands divided by 10 equals 2 ten thousands. 2 ten thousands divided by 10 equals 2 thousands. 2 thousands divided by 10 equals 2 hundreds. 2 hundreds divided by 10 equals 2 tens. 2 tens divided by 10 equals 2 ones. Let's continue to apply this pattern now when we have more than one of a unit. Pause the video and draw place value discs and write a multiplication sentence to find the value of 10 times 4 ten thousands. Here's the multiplication sentence I wrote. Does yours look similar? Pause the video and explain out loud why this multiplication sentence makes sense. You may have said that this multiplication sentence makes sense because we know that 10 times 4 of any unit would give us 40 of that unit. Just like 10 times 4 apples would give us 40 apples, 10 times 4 ten thousands would give us 40 ten thousands. Then we know we can group those 40 ten thousands into 4 groups of 10 ten thousands like we can see in the model, and we can rename those as 400 thousands. Or you may have said that you just know that when we multiply any place value unit by 10, it moves one place to the left. So 4 ten thousands times 10 would give us 400 thousands. Look at this division expression. Read it out loud. 2 thousands divided by 10. Let's start by drawing 2 place value discs in the thousands place. Now we want to divide these 2 thousands into 10 equal groups. Do we have enough thousands to put 1,000 in each of the groups? No, we don't. So what will we need to do? We'll need to unbundle each of these thousands into 10 hundreds. Then we'll be able to divide them into 10 equal groups. Pause the video now and solve 2 thousands divided by 10. Here's how I solved using place value discs and an equation. Does yours look similar? Pause the video to compare your work with mine and make any changes if you need to. Now, so far in our work today, we've multiplied and divided 1 unit by 10. Let's see how the same thinking applies when we multiply or divide 2 different units by 10. Let's draw place value discs in our chart to represent 3 hundreds and 2 tens. Now, what if we were to multiply 3 hundreds, 2 tens by 10? We'd write our expression like this. 10 times 3 hundreds, 2 tens. We put 3 hundreds, 2 tens in parentheses to show that it's one number that we're multiplying by 10. Now, since 3 hundreds, 2 tens is one number that we're multiplying by 10, will we need to multiply only one of the units by 10 or both of the units by 10? We'll need to multiply both of the units by 10. Pause the video now and solve this expression. Here's how I solved using the place value discs and the equation. Let's read this number sentence aloud. 10 times 3 hundreds, 2 tens equals 3 thousands, 2 hundreds. How do we write 3 thousands, 2 hundreds in standard form? We would write 3,200. Now, you may be getting tired of drawing all of these discs. Let me show you a quicker, more efficient way that we can solve times 10 on the place value chart. Rather than drawing all of these discs, we can use the digits. So 3 hundreds, 2 tens. Now, I know that when I multiply place value units by 10, each digit will move one place to the left. So 3 hundreds times 10 is 3 thousands. 2 tens times 10 is 2 hundreds. So again, we get 3,200. Now let's divide 2 different units by 10. Read this division expression out loud. 4 10,000s, 2 tens divided by 10. In this expression, we're dividing 2 different units by 10. How might you go about solving this? You may have said that you could draw place value discs to represent 4 10,000s, 2 tens, and then unbundle and divide. Or you may have thought you can write the digits in the place value chart and then divide by 10. Pause the video to solve this expression and be sure to write the quotient in standard form. Remember, the quotient is the answer to a division expression. Hopefully you found that 4 10,000s, 2 tens divided by 10 is 4,002. Here are 2 different ways that you may have shown your thinking. Which way is similar to how you showed your thinking? Now let's move into the problem set. The must-do problems for the Lesson 2 problem set are on the screen. Set a timer or watch the clock for 10 minutes and work on these problems. If you finish the must-do problems within the 10 minutes, feel free to try any of the other problems on the problem set as well. Today, we found a times 10 pattern in the place value chart. Remember to check in with your teacher, and I'll see you next time for another Eureka Math lesson. Bye!